Hello students, welcome back to my channel. Sorry, in this video we will be discussing questions which were asked on the 1st of February 2023 JEE mains. Okay, so without wasting time, let us continue with question number 12. You can see, if Earth has a mass 9 times and radius twice of that of planet P, then B by 3 root x will be the minimum velocity required by a rocket to pull out of gravitational force P, where V is the escape velocity on Earth. In other words, students, basically we have to find the escape velocity for the planet P, where in terms of VE, where V is the escape velocity for Earth. That's what it means. Now the information furnished is regarding the mass and regarding the radius. Relationship between mass of Earth and mass of the planet is given, and also between their radius is given. So simply we can start. This is a simple question. Now, escape velocity, as you know, for a planet is this. This is the escape velocity for a planet. And as you can see, escape velocity is proportional to under root m by r, because 2 and g are constants. So let us find the factor of change for the planet. Okay. Let us find the factor of change for the planet. So here I will be writing that VE dash will be VE into factor of change. So factor of change for mass is how much? Factor of change will be mass of the planet upon mass of Earth. So since Earth has mass 9 times, so mass of the planet will be 1 by 9th of mass of Earth. Similarly for radius, planet's radius is half the radius of Earth. So this will be 1 by 2. So basically we have 2 by 3. So this x is 2. X is equal to 2. The students who could not understand this, they can use two different formulas, as you know, like this. For the first one, for the planet, we have VE dash is proportional to, from this formula itself we can write like this. Mass of the planet upon mass of Earth, and here this will be radius of the planet upon radius of Earth. Okay. So here it is given that the mass of Earth is 9 times the mass of the planet. Similarly, it is given that radius of Earth is 2 times the radius of the planet. So anyway, you will get this. This V goes up. Okay, this is how you can calculate. Moving to the next question. Given below are two statements, acceleration due to gravity is different at different places on the Earth's surface. This is true, students. This is absolutely true, because as you know that if this is the axis and if this is the equator, G is minimum here at the equator and G is maximum at the poles, because this polar radius is less than the equatorial radius. Okay, and G values universally as r square. So this is less. This is more. This is more, so this will be less, and here this is less, so this is more. So statement 1 is correct. Then coming to statement 2, acceleration due to gravity increases as we go down below the Earth's surface. That's wrong, students. As we go below the Earth's surface, suppose at a depth d, we know acceleration due to gravity is acceleration due to gravity on the Earth's surface into 1 minus d by r, where r is the average radius. So you can see as we go deeper and deeper, d increases, so this factor will reduce. So this is wrong. So statement 1 is correct, whereas 2 is wrong. So A option is the correct option. Moving on to the next question. For a body projected at an angle with the horizontal from the ground, choose the correct statement. You can simply consider a situation in which a body is projected with some speed. Let us say speed is u, horizontal axis is x axis, vertical axis is y axis, this angle of projection is. Now, the gravitation A option reads the gravitational potential energy is maximum at the highest point. Yes, it is maximum because if you take the maximum height as h and if you take this as the datum level or the reference level where gravitational potential energy is treated as zero, then here the potential energy will be mg capital H. And since capital H is maximum, so obviously U should be maximum. So this is correct. Let us go through the other options as well. The kinetic energy is zero at the highest point. This is wrong, student, because at the highest point, the projectile keeps moving with a certain speed, which is the horizontal component of the body, which is u cos alpha. So kinetic energy is not zero. It does not come to rest. That vertical component of momentum is maximum. In fact, vertical component is zero because the vertical component of velocity keeps decreasing as it rises higher and higher, eventually attaining zero there at the highest position. So the momentum will be zero, which is minimum. So this is also wrong. C option. Then D, the horizontal component of velocity is zero at the each point. It is wrong, student, because horizontal component never ever changes during the course of motion. It is always fixed. So this is also wrong. So correct option is A. Moving to the next question. The escape velocities of two planets A and B are in the ratio 1:2. If the ratio of the radii respectively is this, then the ratio of acceleration. So here we have to correlate the escape velocities, then the radius and the acceleration due to gravity. Okay. Now for any planet, if you take m as the mass of the planet and r as the radius of the planet, then acceleration due to gravity on the Earth's surface, on the planet's surface, is capital Gm by r square, and escape velocity is under root 2 Gm by r. Okay. Capital Gm can be replaced by small g capital R square. We can replace this. So substituting this, we can write Ve, that is escape velocity, is under root 2 g r. Now since we have to find the ratio of acceleration due to gravity, let us calculate acceleration due to gravity from here. Squaring both sides, you can see acceleration due to gravity is Ve square by 2r. So this is the formula which will be calculated. So the required ratio, the ratio of acceleration due to gravity of A to B. So G of A upon G of B is equal to escape velocity for A upon escape velocity for B square, of course, upon radius of A upon radius of from this formula. So ratio of escape velocities is how much? 1:2. So this will be 1:2. Ratio of radius is 1:3. So 1:3. So we have 3:4. C option is the correct option. Moving on to the next question. A solid cylinder is released from rest from the top of an inclined plane of inclination 30 degree and length 67 if the cylinder rolls without slipping its speed reaching the bottom. So we have to find the speed at the bottom of the incline. Let us say it is B. Now students, here we have to understand very clearly that when a cylinder or any body for that matter rolls without slipping, no work is done against friction. So in that case, we can comfortably apply law of conservation of mechanical energy, which states that loss in gravitational potential energy will be resulting in gaining kinetic energy. Okay. So remember, students, this is only for pure rolling motion. So I can write the loss in gravitational potential energy is equal to gain in kinetic energy. Now, loss in gravitational potential energy is mg into height lost. Height lost, you can see this is perpendicular equal to hypotenuse into sine 30 degree. So hypotenuse is 60, sine 30 is half. So this is basically 30 cm. So it is 30 cm, and gain in kinetic energy. Remember, it will gain both types of kinetic energy, that is translatory kinetic energy plus rotating kinetic energy. Both types of energy it will gain. So that we have to be careful here. Now, depending on the type of body, immediately we will be able to express I and omega in terms of V and R, etc. etc. Now, I will see the body is a solid cylinder and the diameter, the axis is its own axis. So, moment of inertia of a solid cylinder, which is just like a disc, about its own axis is mr square by 2. So, therefore, we can cancel and throw out r square gets cancelled here, and we are left with GH is equal to 3 by 4 B square. So it's a matter of substituting the values. G is how much? G is given as 10. You can see G is 10. H is 30 cm. So 30 centimeter is divided by 100 B square. So here you can see both the zeros gets cancelled. This 3 gets cancelled. And we are left with V square is equal to 4, which implies V is equal to 2 meters per second. Since we have substituted each and every parameter in assignment, we can expect the answer in assignment. Moving to the next question. Moment of inertia of a disk of mass m and radius r about any of its diameter is m r square by 4. Moment of inertia of this disk about an axis normal to the disk and passing through a point on its edge. So let us draw the diagram to understand properly what is happening there. So this way we draw the diagram. So this is a disk, you can see, students, and the axis is perpendicular to the plane and it passes to the edge. So let us mark this axis as y dash. So we have to find y dash. Now we will be applying parallel axis theorem, which states that if you consider another axis parallel to this axis and passing to the center of mass, and if you know the formula for moment of inertia for the body about that axis, then it will be m plus mr square, where r is the separation between the two axes, which is same as the radius here. So here ICM is simply mr square by 2. We know this, okay, and this is mr square. So finally we have 3 by 2 mr square. So x is 3. Moving to the, that's all students in this video. Thank you so much for watching.